plus. 2 minuses give me a plus, right? So I get plus. What happens when we put in like, we could put in like -1, for example, as a test point. -1 squared is 1. -1 minus 1, negative. -1 minus 3 is -4, negative. -1 plus 4 is 3. So we're looking at plus, minus, minus, plus, positive again. Hey, we didn't change signs, right? We went from plus to plus. That's interesting, isn't it? Because before, as we went across 3, we flipped from plus to minus. And we went across 1, we flipped from minus to plus. Yeah, well, that's the question, is what happens when we plug in like -5, We've got what? We got a positive, 25, -6, -8. Now downstairs we got -1 cubed, which is what? Still negative, right? So we've got plus, minus, minus, minus. We got 3 minuses. We flipped signs again, didn't we? So what's the deal? Why is it some numbers make the signs flip from positive to negative and others don't? What's the difference? Can you tell in advance? Like, is there a way to know this in advance without actually plugging these numbers in? Well, if we could see the graph, then I agree. If we had the graph, like, we don't even need to do any of this, right? Like the graph, we could just like straight up read the answer from. Graph has everything. Incidentally, we could also use this to make a graph later. What's the difference between like 1 and 3 and 4 versus 0 as you look at this expression? 1, the 3, the 0 versus the 4. What's the difference in the formula? Let me put a 1 here and put a 1 here. And, this is the first power, this is the first power, this is the third power. If our factor is raised to an odd power, when we transition across the corresponding algebraic critical numbers, we'll change signs. Like, because this is an odd power, we changed. Because that's an odd power, we changed. Because that's an odd power, we changed. In contrast, for 0, which is an even power, we bounce. We just stay plus to plus. So if you know that, if you think about it, all you really need to do is check one test point, and then you can use this rule to generate the rest. See, I didn't really need to plug in 2.5, -1, or -5. If I plug in 1 carefully and I use that rule of thumb I just shared with you, you can just write down the others without further calculation. I said that the signs only changes at x equals to c when either x minus c or is in the expression. So the sign only changes if the corresponding factor in the rational thing we're looking at has an odd power. If it's an even power, nothing's going to happen. And you can kind of ignore even powers as you start thinking about it, because whatever goes into them, it's either a minus to an even power, which is positive, or it's a positive to an even power, which is positive. So really, if you take a step back and look at your life, you'd realize we could have been ignoring the even power stuff in the sign analysis from the start. But anyway, so what's the answer? In interval notation. Uh-huh. -4. Now, is that going to be included or excluded? I'll tell you what, I'll throw equality in here just to make that question interesting. What's that? Still X, but I put the equals. I put the equals, man. Nah, it was a trick. It was a trick. You should have stuck with excluded. Well, that wasn't friendly. No, the reason it has to be excluded is because if we plug in -4 here, yeah, we're in a world of hurt. Like, I mean, divide by 0, it's no bueno. And then union what? Positive 1 to 3. Now, I'll write the 1, I'll write the 3. You tell me, are those included or excluded? Well, that's not automatic. I mean, certain kind of critical numbers we include, certain numbers we have to exclude the ones that make division by 0, but we include the ones that make equals to 0 when we're dealing with like less than or equals to 0. So that's why these are included, because they're in the numerator. So I could plug in 1, I could plug in 3, it just makes this expression 0. Included, yeah. The difference with the -4 is it would give us division by 0. Let's see here. So I better pick up the pace to get this problem done, right? So I'm going to take off the gloves here for a second. So what I've done is moved everything to one side and made a common denominator, because I want to combine it into a single rational function so I can use the technique I just went over in the previous example. And that gives me 4x minus 3x minus 3 minus 2 times x squared plus x, all divided by x times x plus 1, greater than or equal to 0, which gives me minus 2x squared. And then I need to collect my x's. Like I've got a 4, a minus 3, minus 2. See, yesterday when I made a problem up, the x's just canceled out. It was cool. This one, the x's did not cancel out, which means it's not as nice. See, we've got 4 minus 3 minus a minus 2. So I got minus x, actually. And then minus 3, I think. Oh, this is most unpleasant. Let's see here. So factor the 2 out. Well, minus 2 out. Oh, hurting my brain. Pesky fractions. Now, to check whether or not I'm right on the factoring the 2 out, try multiplying minus 2 through and see if we get back to where we started. I get minus 2x squared. Yeah. Minus 2 times x over 2 gives me minus x. Good. Minus 2 times 3 halves gives me minus 3. Also good. Can you factor what's in the numerator there? X squared plus x over 2 plus 3 halves. I don't want to try. I'm going to complete the square. It's easier. So what's a half of a half? A quarter. So 1x plus a quarter squared minus a 16th plus 3 halves. Oh, fantastic news, my friends. Fantastic news. See, because when I completed the square, you know what I saw? I saw that I was subtracting a 16th and adding it to that 3 halves. Which one wins? The 3 halves. So what does that mean about that numerator? Yeah, well, it would be strictly positive if it wasn't for that pesky 2 out front, but yes, positive. It is positive because this is how many sixteenths is 3 halves? 24. Is plus 23 sixteenths. Great. So my point to you is the numerator is irrelevant. Hooray! It was relevant in the example I worked last class for the other section, because we ended up with like x squared minus 12 or something in the numerator. So like we picked up 2 critical numbers from that numerator. In this one we did not, because this is positive. I mean, so the numerator is always negative, and I'll draw the number line up here. We have 0, we have minus 1, and we have 0 to contend with. If you plug in, say 2, if you plug in 2, we get negative upstairs, positive, positive. So we get minus plus plus, which is minus. And then, using the trick I just shared with you guys, you tell me what happens. We cross 0. It's odd, we get pluses. We cross that 1, since that's just appearing as an odd power, namely 1, we get minus. And so the solution to this is what? It's minus 1 to 0. That's where this is greater than 0. And correspondingly, that's greater than 2. And are minus 1 and 0, are they included or excluded here? Yeah. Yeah, excluded, right? Because we got division by 0 at those. So there you go. That's the answer. Sorry I had to hurry through it, but I know your time is up. So there you go. But you can watch the video later, and you can like slow it down to like quarter speed if you want. You know, you can put it like half speed, put it on loop. I don't know. It's all good. I need to hit the stop record button on that.